All right then. I was going to do something goofy today, and my wife goes, "Don't do it! Don't do it!" So, whatever. All right, Math 8. Let's get this done. Okay, our homeboy work was that worksheet from the workbook 12-2 AB 1, 2, 4, 8, and 9. Okay, write yes for sides that form a right triangle and no for sides that don't. Prove that each answer is correct. Okay, let's see what it looks like. Well, they gave us all three sides, so I plug in all three sides. 7 squared plus 24 squared equals 25 squared. The left side, 49 plus 576, adds up. Yep, they're equal. Number 2, 30, 40, and 45. 30 squared is 900. 40 times 40 is 1600. 45 squared is 2025. Left side equals the right side. Nope. Not a right triangle. That right angle might be off by just 1 degree. Instead of it being a 90, no box, it could be an 89 or a 91 or an 89.2, who knows, but it's not exactly a right triangle, so that's why we're putting no here. Number 4, 10, 15, and 18. 10 squared, 15 squared, add them up. 18 squared, 324. Nope, not a right triangle. Hopefully you got those right. Hopefully my hair grows back. What? No comments from the peanut gallery back there? Okay, number 8. Let's see what's going on here. A school wants to build a rectangular playground that will have a diagonal length of 50 yards. How wide can the playground be if the length has to be 40? Okay, I gave you guys this drawing here. This is the length, and they gave us that it's 40. They gave us a diagonal being 50. We're finding the width. Remember, when you have a length and a width, the width is the shorter side. We're finding this. Can we solve that? Yes, we can. We have a squared plus 40 squared equals 50 squared. Let's see what happens. Remember, your hypotenuse always has to be the longest one. That's going to be your C. Follow the arrow. There's the formula. If I would have had C squared equals A squared plus B squared, remember, it's the same thing. Okay, we have B and we have C. Let's find A. 40 squared, 1600, 50 squared, 2500. So A squared equals 1600 plus 2500. Remember, the 1600 has to go, and so does the squared. Let's get rid of the 1600 first, subtract it from both sides. These two are gone. A squared equals 900. Square root of both sides. A is 30. Let's go back up here. Remember, a 3, 4, 5 is a classic right triangle, so a 30, 40, 50 is also. All right. Let's take a look at number 9. It says, a 250-foot length of fence is placed around a three-sided, I was going to say tree, around a tree-sided animal pen. 2 of the sides of the pen are 100 feet long each. Does the fence form a right triangle? Prove your answer is correct. Okay. It's going to look like that. It's going to be 250 total. If that's 100 and that's 100, I think something's not going to work out here. Let's take a look. Okay, that's the same thing I drew. Remember, if it's 250 total and they're telling you that A and B are 100 each, you've only got 50 left. 50 has to be your hypotenuse, which is the longest side. It's not going to work. I wrote, no! The third side would have to be 50, which is less than the other sides. The hypotenuse must be the longest side. Must be. Making sense? They tried to fool you. Hopefully they didn't. Okay, I was debating going over this next section, 12.3, and I think we're going to go over just for a goof. It says, so we're on page 389. Let's see what's going on here. Distance between 2 points. We've done that. Pythagorean theorem in the coordinate plane. The figure shows a right triangle. Approximate the length of the hypotenuse to the nearest tenth using a what? Using a calculator? Wow. They're making it easy. Okay, find the length of each leg. Well, you can count on here because you got boxes. You can go 1, 2, 3, 4. That's 4. To find the other side, it's 1, 2, it's 2, and you're finding C. As long as that grid's there, and they already gave you numbers here to tell you what it's going up by, makes it easier, doesn't it? Okay. Let's go over here. So we're plugging in what we know. They're saying that A is 4 and B is 2. Doesn't matter as long as C is C, right? A and B can be either one, doesn't matter. So 4 squared is 16, 2 squared is 4, nice 4. See how they skip steps here? So the square root of 20, you're taking the square root of both sides. C equals that, and it's 4.5. Let's do the without a calculator, just for a goof. Okay, square root of 20 is here. I need 2 perfect squares, one here that's less and one here that's more. I look at that and I go, well, either way, because 25 is close, which is 5. And the next, if I went this way, I remember my rule, I always go down 1, and then I square it, and I find the other one. It's easier that way. Okay. Not to confuse you, but from 16 to 25 is a length of 9. From 16 all the way to 25, it's plus 9. From 16 to 20, it's plus 4. So it's 4/9 of the way there. Isn't half of 9 4.5? 4.5 would be half of 9. So it's close to halfway there. Because if 16 plus 4 is 20, the rest of this has to be 5. And add these two together, and you get this distance here. So 16 plus 9 is 25, 16 plus 4 is 20, 20 plus 5 is 25. My math is correct here. So it's close. It's approximately halfway, and look what they put. Approximately 4.5. So if you didn't have to be super accurate, yeah, you'd come up with about 4.5 just doing what I did. I didn't say this stuff's easy, but every time you see it, it gets a little bit easier. Okay, then they're showing you all this, blah, 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 blah. Then they say, your turn. Okay, watch this. We don't have any numbers here, but we can go 1, 2, 3, 4, 5. Okay, that piece is 5. That side's 5. And over here, these are the numbers on the graph, right? Not any numbers with the problem. So from here, it's 1, 2, 3, 4. That side's 4. So I've got C squared equals 5 squared plus 4 squared, whichever. 4 squared plus 5 squared, doesn't matter. So I'm putting it A squared plus B squared. I'm not even sure what I picked here. I know it's either 4 or 5 for A, and I put 5. I called this A, this one's B, and this one's C, the hypotenuse. If you square it, 25. If you square it, 16. 25 plus 16 is 41. Oh, jeez. It's not a perfect square. Square to both sides, and you get 6.4. Okay. I'm not spending time going over how I got 6.4. They're saying use a calculator, whatever. we could, remember we guesstimated a problem like this on the homework from the worksheet 12-1, and I think it was that exact same numbers, the exact same stuff. It was 41, I think, pretty sure it was. Anyway, watch this. Here's what this lesson is. Distance between 2 points. What they're saying here, they're not going to give you the grid. Watch this. I took this problem right here and I copied it down here a bunch of times. Watch. So if they didn't put numbers here, we could find them like we did. 1, 2, 3, 4, 5. There it is. 1, 2, 3, 4. There it is. A, B, and there's C, right? Not a problem. But what if they did this just to make your life miserable? And they said, no more blue grid on there. Uh-oh. But you still could figure it out. From this dot to this dot, 1, 2, 3, 4, 5. Because you can see the numbers here. They're counting by 1. 1, 2, 3, -1, -2, -3, -1, -2. Okay, so we know that the top one is 5. And this one here, well, if this is -2, that means this is +2. And from here, I go down 1, 2, 3, 4. It's the same exact problem that we just saw. 5, 4, and C squared. What if they did this just to make your life really miserable? What if they took away the entire numbering on the grid? Now you have no idea what's going on there. This could be 0 and this could be 1. This could be 0, this could be 100. That could be 0, that could be 0.5. We don't know. Now you're going, oh, geez. But if they gave you coordinates of a point, now you can find it. Uh-oh, somebody wrote on here, dang it. I think somebody broke into my house and wrote on my surface here. So what if they gave you this situation? And you go, okay, let's see. Could I find the distance from this dot to this one? We're going horizontally. Remember the grid is a horizontal and vertical number line? Okay. So what's not changing here? See, the height is 2. The y value is 2. Those aren't changing. What's changing is it's going from left to right. That's what's changing. So watch this. Okay. So the height stays the same. No change there. Okay. So we can get rid of y on both of these. From -3 to +2, if I were on a number line, wouldn't I go +1, +2, +3, +4, +5? Yep. So I would call this side 5. And if I came over here and I realized the x isn't changing for this one, it's the y that's changing. The x is 2 to the right over here and 2 to the right over here. So what's changing here is the y. So from 2 to -2, that's what's changing, because we're looking at this side right here. Okay, so from 2 to -2, if I'm on a vertical number line, it's going to be 1, 2, 3, it's a change of 4 units, 4 steps. And so that's going to be 4. Wasn't that what we had before? Sure looks like it. This one was 5, that's 4, and that's C. So if they give you the coordinates of the point, you can say the x's here didn't change, but the y's went from 2 to -2, or -2 to 2, either way. And it's going to be a positive number, because I don't think you can really have a triangle that's got, it's, how big's your yard? It's -40 feet long. Really? -40 feet? I don't think so. So it's got to be a positive number. And they were talking about absolute value, and that's in this, on those pages, they're talking about absolute value because you're not going to have a negative distance like that. Okay. So, don't stress about this. You can look it over in the book. This stuff's difficult. I was thinking about not teaching it, but I thought, you know what? You're seeing it now. You'll see it again next year. It'll be in your head, and it'll be easier the next time you see it. Okay, on page 391, same thing here. Finding the distance between 2 points. Okay. Homegirl wants to find the distance between her house on the side of a lake and the beach on the other side. She marks off a third point forming a right triangle as shown. The distances are measured in meters. Okay, so we're looking at the x. So the y is the same vertical distance, up 20. So this distance here is what we're finding. Well, they're saying 10 minus 280, which is negative 270. And they're saying absolute value down here. That's why it becomes positive 270. You're not going to have a negative distance. You could have said 280 minus 10 and it's the same thing, 270. So this distance here is 270. For this vertical distance, notice how it's 280, that's 280, and that's 280. So we're looking at the vertical distance. We're getting rid of the x, and we're saying, what's the change in the vertical? 164 minus 20, it's going to be 144. So there's your sides. They're taking absolute value in case you're saying, like over here, 10 minus 280, and it's going to be a positive number either way. And then they did the math. Look at this. Remember the bottom is 270, the one going up the side is 144. You're taking the formula, the theorem, square 270, square 144, add them up, square root, and this side here would be 306. That's the longest side, 270, 144, and that distance would be 306 for the hypotenuse. And this problem here I was looking at this part here, the math talk, and it says, why is it necessary to take the absolute value of the coordinates when finding the length of a segment? And here's the reason. Take the absolute value because the length of a segment cannot be a negative number. How far is it from here to the beach house? It's negative 270 feet. Really? You're probably smoking your socks then, because that makes no sense whatsoever. Okay. You can always stop the video and copy that. I know I went quickly, but you can always go back and look at it. You can watch it a million times if you want. Okay. Remember, keep watching those math antics videos. Watch them all. Watch them 10 times. It's going to put a lot of really good math skills into your head, and it'll really help you. All right. Let's go to... I might give you guys a quiz. Not today. And remember, all the stuff we're doing, it's only going to help your grade. So work really hard, because it's going to make your life easier next year. Plus, it'll help your grade this year. But if I give you a quiz, just work on it. It's only going to help your grade. It's not going to count against you and make your grade go down. Okay, see where it says page 395 down here, ready to go on? Let's take a look at that. I'm going to talk about this other part down here on Friday. So let's just do 1 through 7. You know what I want you guys to do? Do it by hand. Don't do a calculator. Use a calculator to check your work after. Write them all out. 11 times 11, 60 times 60 equals 61 times 61. Write it all out and then check it with your calculator to see if you got it right after you've done it. Or just cheat, either way. But I would practice, because it's always good to practice multiplying and adding. Okay, that should cover today's lesson. I got absolutely nothing to do, so no, I got a lot of work to do. So let's cut this a little bit short today with my assistant back there, ready to end this.
Yes.
All right then. We'll see you guys on Friday.